Okay, our next presenter is Robert Griffin Nolan, who is from the biology department and specifically the graduate degree program in ecology. And the title of his presentation is When Grasses Succumb to Drought, a Plant Physiological Approach to Understanding Grassland Carbon Uptake During Drought.
Climate change is expected to cause droughts that are reminiscent of the Dust Bowl. This trend is already becoming apparent in places such as California and southern Africa. For my research, I'm interested in how droughts such as these will impact our native grassland ecosystems differently. And yes, grassland ecosystems are different around the world and even within our own country. For instance, this is a desert grassland in New Mexico, and below that is a tallgrass prairie in eastern Kansas. Grasslands cover more than 30% of Earth's land surface, and they provide us with the valuable service of absorbing carbon dioxide that's emitted from burning fossil fuels and converting it into plant biomass. By studying natural droughts, researchers here at CSU have shown that these grassland ecosystems vary in their sensitivity to drought, where more sensitive ecosystems are unable to absorb as much carbon from the atmosphere as they would under normal rainfall conditions. However, we're unsure of why these grasslands vary in their sensitivity to drought. And that's where my PhD comes into play. I study how individual plant species respond to drought at a physiological level in an attempt to explain what's happening at the ecosystem level. Specifically, I study how plants are able to transport water as water becomes limiting, such as during drought. For every molecule of carbon dioxide that a plant absorbs, up to 400 molecules of water are lost to the atmosphere. So it's clear that continued transport of water is necessary for carbon uptake to occur. Plants can be thought of as small plumbing systems that are operating under very low pressure. In fact, they're operating under negative pressure, meaning they're pulling materials from the soil, such as water, into them. As water becomes scarce, such as during drought, the pressure inside of a plant becomes lower and lower until eventually bubbles of gas can actually come out of solution inside the plant. The same thing happens when you pop open a can of Coke, decreasing the pressure inside and releasing bubbles of carbonation that were previously dissolved inside the soda. But while the bubbles in a soda are enjoyable to you, the bubbles inside of a plant can entirely block the flow of water, similar to a blocked artery. Using innovative imaging technologies, I plan to determine exactly where these bubbles form inside plants and how some plants are able to make them disappear. By experimentally inducing drought, I'm able to measure the decline in the flow of water through a plant due to the formation of these bubbles. And I've shown that species vary in their ability to tolerate these bubbles in the same way that ecosystems vary in their sensitivity to drought, where more sensitive grasslands are inhabited by species that are unable to tolerate these bubbles and end up looking like this guy over here. An understanding of this process is important for climate modelers so that they can better understand how ecosystems are able to absorb carbon dioxide from the atmosphere during drought. And this is one of the main uncertainties of the global carbon cycle. Thank you.